Welcome to the lecture. It is the third lecture of the sixth unit, that is total station. We'll go into the brief about what we are going to study today. We are going to study the applications, where what are the uses of the total station. We are going to study how to set up a total station. We want to see today. These are the two things we are going to study in this lecture. Now, next, the first thing is applications or the uses where this total station is useful. The first point, measurements of horizontal and sloping distances between the stations. You can calculate the horizontal and sloping distances between the station. Baseline measurements of the triangulation works, means the distance. Missing line measurements or the obstructed or the omitted measurements can be calculated. It automatically calculates elevation of a measurement or the remote elevation measurements also. It's a point which is far away, whose point is to be elevation is to be calculated, which is visible. Far away means which is visible but not in direct axis. Measurements of horizontal, vertical and oblique angles between the lines and the objects, along the lines or the objects. Establishing absolute positions of the stations and the ground control stations. When you want to set up a ground control station or a absolute position of the stations, so in that case this total station help you to establish it, because that requires a very great accuracy to set up a ground control station points, because if there are any errors, we'll come back to these ground stations. With respect to that, we are going to again carry out, that becomes a reference point, right? Contouring, mapping volume area measurements through suitable softwares or the connections to the computer can be done, right? All this can be, will get in just a few seconds with the help of some softwares which are required, right, to process this data. Fixing 3D coordinates of a station with respect to a reference station point. As I said, we'll get the reference from the reference station point. You'll get the x, y and z coordinates, that is 3D coordinates, right? You get the three coordinates, that 3D coordinates, 3 direction coordinates. Setting out a works for an important civil engineering works, like projects like dams, bridges, canals, tunnels, which are very expensive ones and very of important category, which are very important one and very expensive. Next is setting up of total stations. Setting up of total station is way similar to the way you have leveled the set the theodolite. It is almost same. Some differences are there that we are going to study today. Prior to observing the distances and the angle, the instrument first, right? The instrument must first be carefully set up over a specific point. Setup process easily carried out using the following steps. First, that is tripod. First thing, you have to set up a tripod. Tripod is the 3 legs that you have seen, right? 3 legs of a total stations, that you have to set up it properly, right, over a point, it is a station point, and see whether the tripod is level. If you see the plate, the tripod plate, the upper plate, right, it should be level approximately. Manually check the tripod is level and centered on the ground point. Whether it manually check the tripod level and the center of the ground point. Firmly place the legs of the tripod in the grounds and extend its legs so that the head of the tripod is approximately level. So what is trying to say is, when you have checked the center and the level, once again, if it is not level, then what you're going to do is you have to adjust the legs. You can increase the length of the legs or decrease the length of the legs, right, with the help of a knob. So you're going to increase or decrease the length of that leg so that the instrument, the tripod is in the center and level also. Attach the instrument to the tripod and center the foot screws. Means what? If you have seen the theodolite, the foot screws that are there, right? It should be at the center of that screw. It should not be one should be up or one should be down. It should not happen like that. What's the example? If this is your foot screw, right? This is your foot screw, sorry, and this is your screw, right? The foot screw. This is our foot screw. This should be neither at the top, neither at the bottom. It should be at the center here. All the three foot screws should be at the center. It becomes very easy if you bring it to the center and if you do the leveling. It becomes very easy and fast to level the object. Next, turn on the instrument, right? Once you have set up the instrument and you have leveled it, right, with the help of the foot screws, turn on the instrument. Laser plummet will activate automatically and the level plummet screen appears. Means what? Whether your instrument is level or not, it can be checked through the digitally. It is not manually, it also can be calculated through digital means. On the screen, it shows you the bubble. It is bullseye bubble. It is like this. This is your bubble, water bubble area, in which there will be a small center, and this will be your bubble. If it is not level, it will be around this circular path. When you can say it is at the center, when it is inside the bullseye. When it is inside the bullseye, that means it is leveled. This type of arrangement you can see that is shown on the screen display. Next is, if necessary, move the positions of the tripod legs to make a large adjustment to the center the plummet over the ground point. When you want to center the plummet, means what? When you want to bring your center of the total station to the center of the ground point, that time you use the laser plummet, right? So center it to bring to bring this instrument to the center. Same way, here you are going to use the legs because we have leveled it and we have centered it. So in this case, we are going to just move slightly the legs. Use the foot screws to make small adjustments to center the plummet over the ground. When you have very small adjustments to bring the instrument to the center, that time you have to use the leveling foot screws. Your foot screws you have to use. Keep in this mind. Whenever you want to do these small adjustments of the centering, you can use the foot screws to bring it to the center. Adjust the height of the tripod legs to level the circular bubble. Note, do not move the legs from the positions, just lengthen or shorten them. You have to not change the position of it. You have to just increase or decrease the length of the legs one at a time. It is not all, one at a time, as necessary to bring the bubble to the center. Right? This is all approximately. We will do that permanently with the help of the foot screws, because once we bring the foot screw to the center as shown you in the previous slide, and you need to start turning directly the screws either clockwise and anti-clockwise. If it is very uh, irregular surface, then it becomes you have to turn the screws a lot, right? You have to turn these foot screws a lot. So for that, for easy adjustments, we do all those things, right? After this time, your instrument should be very close to the level and very close to the ground. Check the plummet or the level circular level bubble to verify this. If this is not the case, you have to repeat the plummet and rough leveling steps above. Otherwise, continue on the next step. If it is not properly leveled and centered, once you are checked, then you have to carry out the rough leveling and centering again. If it is correct, then move on for the next process. Right? See how this is happens. This is what is a circular level bubble. Right? It is also called a bullseye level. Now the same thing, once you have done the rough leveling, or all the levelings and centering is been done, then you are going to use the foot screw leveling. What foot screw leveling is? You are going to take the 2 foot screws and make the telescope parallel to it, and then turn the telescope either clockwise or anti-clockwise direction. This is your telescope, right? These are your foot screws which are parallel to it. Both are parallel, right? These are parallel to each other, either clockwise or anti-clockwise, right? Either inwards or outwards. Both should be in one direction. Both should be either inward or both should be either outwards. You have to turn the foot screws until the till bubble in the tube will come at the center, till the bubble comes exactly to the center of the tube. Once this is done, now you're going to use the third screw. Now you're going to make what? Actually, you have 3 foot screws. In the first case, you made you made the telescope parallel to the 2 foot screws, that is 1 and 2. This is your 3. Now what you're going to do is, you're going to make telescope perpendicular, right, to the third screw. To the 3rd foot screw, you're going to make this telescope perpendicular. Now again turn the foot screws either in clockwise or in anti-clockwise direction. In the second, you have to do it with only 1 screw and bring the level at the center of the bubble tube, and check by rotating the telescope in all the 360 degrees, right? If once you again rotate it and stop, the bubble tube should again come and stand at the center. If not, you have to again repeat this procedure of bubble tube leveling, right? If it is correct, then move for the next process. This is how it is. First, for first 2 screws, level parallel to it, and for the third, that is C1, perpendicular to it, right? We saw for today's class, here we will be stopping it. We'll see other things in the next class, right? So we saw today that it is we talked about the uses or the applications, you can say, where you are going to use the total stations, and now how to set up an instrument, right? We saw that also, because the process here is little bit lengthier, but if you do the rough leveling properly, then your screw leveling and other centering purpose will become very easy and fluent. right? That's all for today. Thank you.